When we wake up, we are in a state of fasting. Fasting is the metabolic situation that is normally produced in the morning after not eating for 10 to 14 hours at night.
Glycogen is a polysaccharide that it is stored in the liver as an energetic reserve. In a fasting state, it gets converted into glucose, which will help to maintain normal blood glucose level. However, this glycogen reserve gets depleted and the blood glucose starts falling. Some tissues in the human body can only use glucose as a source of energy.
As a consequence, hypoglycemia. In other words, our body must use reserve to obtain the energy necessary to survive. The main priority in fasting is that there is no lack of glucose to the brain and erythrocytes that are dependent on glucose. The muscle, after depleting its own glycogen reserves, will use its large reserve of triglycerides and fatty acids obtained from them, including the ketone bodies, before resorting to the use of their own protein and amino acids.
As it was said, some substances like fat, amino acids, and also pyruvate can get converted into glucose by a process called gluconeogenesis. This process can be defined as the synthesis of glucose from non-carbohydrate sources. In the gluconeogenesis, about the 50 and 60% takes place in the liver and a 40% takes place in the kidneys. There are some metabolic reactions that are involved in this process, like glycolysis and Krebs cycle.
When we digest sugar, enzymes in the small intestine break it down into glucose. This glucose is then released into the bloodstream, where it is transported to tissue cells in our muscles and organs, and this is going to be converted into energy. Glycolysis is a series of reactions that extract energy from glucose by splitting it into two 3-carbon molecules called pyruvates. It also takes place in the cytosol of a cell. It can be broken down into two main phases, the energy requiring phase and the energy releasing phase. The reactions of glycolysis are catalyzed by its own enzymes. The most important enzyme for regulation are phosphofructokinase. Glycolysis also converts 1,6-carbon molecules of glucose into two 3-carbon molecules of pyruvate. The net product of this process are two molecules of ATP and two molecules.
The behavior of carbohydrates will vary mainly according to the intensity of the exercise performed, the duration of this, the level of physical fitness of the subject that exercise, and their nutritional status. We will use two pathways in the metabolism of carbohydrates. The first one is the glycolysis, and the second one is the Krebs cycle. But when there are no more glucose in muscle and exists hypoxia, starts a pathway called Krebs cycle. That is the responsible of conversion of lactate to glucose in liver.